to my bench again. Last year I did a video where we fixed this little HP 403B. We found a bad transistor in it on this board right here. This little transistor right here, which I didn't mention in the video. I replaced that with an ECG 126A, which worked just fine. I've since gone back and replaced a couple of the capacitors that I had in here that were not right. This one is still fine, and this little weird one here, little 4 microfarad deal, it's fine too, and this one is fine. Everything else on the board is good, and the meter actually worked after a fashion. Well, it did okay, but it wasn't what you would call accurate by any means, and that's because we had this bunch of batteries. Like I said before in the other video, these batteries are made out of unobtainium. I even went to the battery store and they looked at these and they said, "A what?" Yeah, these are ever-ready 6.25 volt nickel cadmium, and the number on them is 5/B225T. And there's, like it says, 6.25 volts apiece, 225 milliamp batteries. Not gonna happen. Can't find those things. I did attempt, and not on video, but I attempted to replace the power supply here. This power supply in this thing, if you can see it down in there, is just charging. That's all it is. Basically it charges the batteries, and I could never get it clean enough to work. I built up this little guy right here, little simple breadboard, plus and minus 13 volts. It uses a what is this thing? The chip on it is a 1468L, MC1468L. You can get plus and minus voltage out of a non-center tapped transformer, which this one is just a non-center tap 12 volt transformer. Well, it's more like 18 volts coming out of it. And you've got your voltage adjust, and on this one you have a little pot that you turn that adjusts plus and minus voltage. And I hung a LM317 off the side of it for the for the 6.25 volts that it requires, because this requires plus and minus 13 and 6.25. Well, it kind of worked, but I could never get it clean enough. It just would not be clean enough. So I sort of put the whole project aside for a while, and I said, you know what, someday I'll figure out how I can get batteries. Well, thanks to one of my viewers, Bill, I gotta look up here. He, hang on a second. You can tell that these videos are well prepared, can't you? Bill, he's a fellow ham, and let's see. Let's see, there it is. Yeah, he's a fellow ham. He's out in California. Bling blong. Of course, my phone has to go off every time I turn on a camera. And his call is K6WHP out in California. He saw my video and said, hey, I got something I can help you with here. And sent me a bunch of these little battery packs. They're, I don't know what the brand is. ELE option. Rechargeable nickel metal hydrides, which are fine. 3.6 volts, 800 milliamp hour batteries. Right there. And he sent me 8 of them to replace the batteries inside of this thing. Thank you, Bill. I appreciate it. Someday I hope to work you on air. Well, with my antennas, which actually amount to not much, well, 90 feet of gutter at 25 feet, I don't get California very often. I did, however, the other day get Australia on PSK, which was really cool. Anyhow, he sent me 8 of the batteries, which would amount to about 30 volts. And I thought, you know what? This thing requires plus and minus 13, so I'm going to try 7 batteries, which would give me 25.2 volts, which I think will be closer to, which is closer to 26, plus or minus 13. And hopefully that'll be fine, and then I'll take a tap off for the 7.2 volts for the 6.2. So we're going to see if this works. I'm trying something new on this video too. I'm trying a different microphone. Let me tell you, tell me if you like this mic better than the one I had. I did print out a little box here to hold the batteries in place. I 3D printed it so that it'll kind of hold them there. So what we got to do first off is we got to take these guys, cut off the wires and hook them all up. If we look at the schematic over here, where is it? Yeah, there it is. Okay. We can see that the power supply basically just has 4 6.5, 6.25, 6.5 volt batteries in parallel, or in series, in series, giving us plus and minus 13 volts, and a tap right here off for your 6.25 volts or 6.5 volts. It doesn't, it appears by the schematic that it's not all that critical as long as your battery voltage is above the 2.4 that it says on the meter when you check it, which would be 24 volts. So we'll see if this works. If it doesn't work, I'll put in the eighth battery and we'll give that a shot. So basically what we got to do here is we got to cut all these guys off, all these little connectors. I didn't bother to go through and do the connector thing. So we'll cut off all of these one at a time so as not to short it out, to short out the battery. And here we go. And of course I will be keeping all these little connectors. They're kind of cool. Never know. I belong to the school of don't ever throw anything away. As a result, my shop is kind of cluttered. Yeah, kind of cluttered. Yeah. Alright, so basically all we have to do with these is strip them all back. I know, riveting, isn't it? Yeah, I know, I don't use wire strippers. I just use pliers backwards, or these things backwards, because I've been doing it so long. And the only wire strippers and someday I'll get a pair of these that I'd like to have, are the ones that the end is heated and you put it around it and pull it. Oh, those are nice. They just melt the wire. Of course, they don't work with Teflon at all. Alright, so okay, we got our batteries here. Now we're going to take and put them all in series. So that means we go, you know, from plus to minus. However, if we're going to do it, we may as well do it pretty and use some heat shrink here. All this pretty little heat shrink, and cut us up. Oh, whoops. Well, we're gonna need a bunch. Yeah. Suppose I could have prepped all of this before I actually turned on the cameras. What do you think? That's enough to get started with. Alright, so we'll start with well, let's tin these guys. Got my that humming or whirring you hear in the background, if you can hear that, I don't know, I'll find out in post, is an old Dell 16-port hub. Well, actually it's a switch that I found at the thrift store for $10. It works just fine, but it has 4 fans in it, all of which run full speed all the time. What is this thing? It's a 3324 Power Connect 3324. It works, so, you know, what can I say? Alright, so, how are we going to do this? We're just going to take, let's show you here, just in case you want to know how this works. We've got a whole bunch of batteries that we want to come up with a voltage to. So if we take the plus to the minus of this next battery, alright, and we test from minus here to plus here, we now have 7.7 volts, whereas here we've got 3.8 volts. So basically you just keep putting them all in series and you end up with all your voltage. So plus to minus, we'll go through and do all of that later. Another little piece of heat shrink. Plus to minus. Another little piece of heat shrink. Well, I should be working for some big production company someplace. These are such, I do such riveting stuff. Another piece of heat shrink. Don't forget the heat shrink. It's like, at least in my business, I go to make a cable and I'm all busy making the cable and don't think about it, get the thing all wired up and done, and then I look at it, I forgot to put the connector shroud over the end of it. So what I end up with is taking it all apart and putting the blinking part back on the cable that needs to be there. That's always fun. And yes, we've all done it. Whoops. I'm just butt splicing these guys together. It's not like they're going to be out being manhandled, so I'm not really all that worried about it. Did I actually remember to do them all heat shrinks? Alright, so let's I can heat shrink these first ones together because that's going to be fine. I've got 1, 2, 3 and these guys here. So let's get a voltage measurement here. Negative. Oh, good. I forgot my lights flicker when I turn that on. Negative to here. We got 15 volts. And we got 11.6. So basically we got 15 volts to there. 11.6 to there. So we're not going to be able to divide that up correctly, are we? You know what? Now I don't want to tear one of these apart to try to get the center tap. So I am just going to do it the way that William did it. By the way, down in the link underneath here, I've got or down underneath this thing, I've got a link to William's or Bill's video and write-up he did on him doing the same thing. He's got one of these things, and he went through and did all of this. Didn't actually make a video of the whole thing being done, but he gives a nice write-up on how to do it and what problems it gets rid of. And it's not just the the batteries are replaced. If you remember in that other video, if you saw it, if you haven't, you really go look at it. The meter wobbles around badly, and you end up with inaccurate readings and wobbly meters. And I thought originally that was going to be due to the caps being bad. Well, as it turns out, a lot of that's due to the batteries not being any good. Okay. Alright, so now let's get our meter reading here. We should have like 30 volts. 31.12 with a center tap of 15.5. Perfect. Let's put this back. Get it off of the bench. Alright. So, let us heat shrink these guys down here. I just use my rework soldering station blower to do this. I can control the temperature, which right now I got set at about 370. Yeah, about 370 Fahrenheit, Celsius. Everything's in Celsius these days. Alright, so turn that off for now. It makes too much noise and it makes the lights flash. Alright, so let's bring this back in the picture here. Oh, I forgot. I'm not going to be able to. Okay, well, whatever. Let's see, this is our negative end. I'm going to have to reprint that because I didn't think this through all the way. So I'll tell you what. I'll stop this video and I'll be back in a minute. Okay, well, so we're back. Got the new box printed out here. Take a look. Right there. With all 8 batteries in it. And we're going to wire this thing up. Here's the old box. I'll hold on to that. Never know when might want to do something with it. Don't know what. So here's our plus, here's our minus. Now we've got to figure out, we want 6.5 volts off of one of these guys, but I think maybe what I'll do is I'll just take the 2 of them and get 7.2. I think that'll be fine. At least, according to William, or to Bill, it works. So we'll try it that way. The way this thing is set up, the plus is over here. It's right there. The negative is here. Oh. Well, wait a minute. Yeah, the negative is here, and this is the 6.5 volts input. So what we got to do, if we look at the schematic, we got to take this right here, this plus 13 volts, and ground. Well, whatever you want to call that ground there, the middle of it, and the minus 13 volts and hook them up. So that's going to be these two. So we're going to need a little bit of wire. I've got little pieces of wire here. Chunks. And we'll start doing that. Let's see, my little pieces of heat shrink over here. So, like I said, you got to use the right colored wire. Make sure the electrons know where they're going. Tin this up a little bit. By the way, it took about an hour and a half, a little over an hour and a half, to print that box. Having a 3D printer is kind of neat. It took me a long time to talk myself into buying one. And the big problem was not actually the 3D printer itself. I knew that was going to be in the $300 range, or somewhere around there. The problem was that the we'll give it some extra. The consumables were so expensive. The consumables cost $25–30 a roll for the filament that you use, and that was a little bit on the prohibitive side. But then finally, the filaments came down some. Now they're down to like $14 a roll, and actually there's quite a bit on a roll. And the that's for the cheap stuff. And then when you want to print something good, you go and get the better quality stuff, which ranges from 15 or 16 or something like that to about $27–30 a roll for really good stuff. And that isn't quite as prohibitive. So I finally went out and bought one. I got one from Micro Center's brand, which works quite well, actually. I was very happy with it. I've printed a lot of stuff off with it. I mean, I've got all kinds of things that I've put together and or printed out, and it's amazing what I can find that I need to print out. Every time I go for something, I say, well, how in the heck am I ever going to make that? Oh, wait, I have a printer. So that's fun. I got another one, too. The little one. I got a bigger one and a little one. I better think about what I'm doing here. Let's see. I did take a picture of this mess before I took it out, which actually helps, by the way. I don't know what we did before we had cell phones. There it is. Yeah, so I wonder why sometimes the cell phone does its pictures upwise and sometimes it does them sideways. So that's, all those are time series. And then I've got let's see, the purple one goes around to there, and the black and white one goes to there, and it's all marked on here. So 13 volts battery, ground 13 volts. So The black and white one goes to our center tap. What did I do with the center tap? Hello? Did I hide my center tap? Did I? No, I didn't hide it. There it is. I just pulled it over. Oh, that was smart. Not exactly. Get out of the way. There you go. There we go. So we need a little piece of black wire. Anyway, I've used my printer for lots of interesting things, even down to the point of needing knobs. I had a busted knob on my 332A distortion analyzer, and I printed a knob for it, and it came out quite nice. And I've used it for many things. Oh, this is going to be tricky. Yeah. This right here is where you wish you had a third hand growing out of your chest. Ow! That's hot. Okay, there we go. Got the center. Right there, supposedly. Okay. I'm going to leave that. Well, actually, I'm going to leave that off for now. And then this is the ground one. Let's see, purple. The purple wire. Come on, stand up. Sheesh. Yeah, the long purple, short purple wire went to. It's negative. Went to short purple wire went to that black one right there. Right, so we'll chop him off. Short purple wire. Goes to ground. Don't forget the heat shrink. Solder him on there. And that I can heat up. Looks like my mic's picking up some really strange noises. It must be from this thing over here making noises. The thing I used to shrink up my heat shrink, which is actually my thing here, goes down to short purple, or whatever color that is. Yeah, it's my yep, you're off. Okay. You go to there. You go to here. Goofed it up. Gotta put on my geek glasses so I can see what I'm doing. Okay. You, a piece of heat shrink. You go to here. I'm just double checking myself, making sure. Okay. Okay, I'm going to leave that off, and we're going to take some measurements. Alright, so we got, I don't know why I did that, but okay. So from this to here, hello, minus 15 volts. Okay, so that's going to be correct. That means that we can tie this to here. Yep, I got solder. Or no, what do you call that thing? Heat shrink on it. That's not clean enough. I have plenty of extra, so we'll give it a new little bit here. So there's that. That I know is right. And I'm going to heat shrink that up. There we go. And then this guy, I want to go to around to here. So I'm going to have to cut this piece of heat shrink off of here. I shouldn't have put that on. That wasn't real bright. You know what? See if I can do this without slicing my finger. That would be good. Now, we want to take and find us minus 7.7 right there. So we'll open this up. Get another piece of heat shrink here. Slide him over and down far enough so that heating him up doesn't cause any problems. And okay, this is going to be interesting. Anyway, interesting balancing act here. Get those three all smashed together and soldered. Well, that was interesting in kind of an unfun sort of way. The camera's quit recording. Anyway, so redo this thing. I got them all wired up. I got my plus over here, my negative over here, my ground, my minus 6 volt tap here, and my ground there. So let's get everybody out of the pool. Alright, and let's put the board back in. And the board goes in this way. Make sure everybody is not pinched or hurt in any way. It's not. The board just sort of slides in here like this, and all those little guys come up on top. And it grounds back here. So, yeah, I got big old long screws that go back in all of these parts. There's one for here. These, oh, those are not long, those are short. Okay, so these go here. I don't know if I like having this mic here. It sort of gets in the way. I don't know if it's actually even a big deal as far as audio goes. I'll find out when I put this thing together. Got to be careful when you put these things together because they do have two grounds. They got a number 1 ground and a number 2 ground. And if you get them mixed up, it will not work. Okay, so let's see. This one is black, or white, yellow, green. It goes here. Nice, I'm going to mark them for you. This is green and white, and it goes here. And this is white yellow. Well, this is white black. It goes here. And then this one is white yellow. And it goes back here. Oh, okay. Then over on this side we've got white brown. Okay. White and sort of brown. This one is white violet. This one is white red. This one here. No. White red, white violet, white orange. It goes here. That's interesting. What does that say? White brown, white violet, white red. So that's white blue. Right. That one's red. That one is definitely violet. That one is blue. So white violet says it goes right there. And that one just says white, so it's white. Okay, so white blue goes over to this one, I guess, because they ran out of room to print them, evidently. Okay, and now we gotta screw down the back pieces here, and those take these longer ones. I don't know why, but that's what was in it. So I think, no, they weren't in there. They were these flat ones, but boy, they sure are long, but that's what came out of it. It's not like you're going to hit anything under there. There's nothing under it. Okay, and one more over here. This is sprung just a little bit. Probably shouldn't have tightened up the screws in the front quite as tight. It would be easier to get that in, but there we go. Alright. So, everybody is put back in and screwed down. Let's see if we got this thing. Battery test, well, it's greater than 2.4, that's for sure. It's 3. Let's turn it on, and we got is that nope. Okay, so it looks like we got to do a little bit of an alignment on this or something. So loop gain adjust. We'll find out how this works here in a minute, but let's find out if the loop gain. No, not the loop gain. It does have meter cal is this one, and then this one. So we may have a problem here. Let me check everything out and I'll be back. Alright, well, got it all put back together again, and I got the parts all put up on it as much as I can. It's still open and sitting here on the bench, but what we want to do now is we want to find out if it's accurate. So I've got my little single generator here in this picture, and I've got the meter over here on this side, and over here I've got my scope, my LaCroix 9314, which is just convenient because it gives me RMS output, which this meter is supposed to read. So let's start off and see how we're doing. So right now we're sitting at 0.28 volts on this meter, or on this generator. Wait a minute, let's take this down to 400 hertz. Okay, yeah, this thing's off. This thing is off a lot. It's not good anymore, but I can read it over here on the LaCroix. Okay, so what we've got, if you look at the LaCroix, we've got 400 hertz. We're feeding it out of this little guy, 0.28 volts, which is approximately 0.25 or whatever. This thing puts out like peak to peak. And we've got about 88 millivolts of RMS. So if we take a look over here at the meter, we're sitting on the 0.1 volt scale, and we've got about 0.86, well, 0.88, so 0.88, that's pretty good. Alright, and that's on 400 hertz. Now, let's take this up to 300 kilohertz, which is what it says to test it at. And if we look at the LaCroix, we're sitting at about 286 kilohertz, close enough. We've got the same input, which is 0.28, and we got 0.88 output, and this has really only changed a tiny little bit, so that's pretty good. Let's take it over to, let's take it up to 1 volt. Volt output. Go over to the LaCroix, turn this down. Okay, LaCroix says that we're at about point. Our peak output right now is right at 1 volt. And we should be reading about 3.58. And we're reading about over here, about 3.2462, somewhere around there. That's actually within specs. I don't know which one of these is right. This is bouncing around some. So let's take it up, and that's at 286 kilohertz. Let's take it down to 400. And nothing has changed. We're still sitting here at about 3.6 or right around. So let's take the output one more time. Let's take it up to, let's take it up to 5 volts. Peak to peak, which we're reading, let's see, 4.98, 5.06, 4.98 peak, and we should be reading about 1.77, which makes sense. So we're looking here at, on the 3 volt scale, about 1.5675, 1.66 at 400 hertz. And let's take this thing up to, again, to our 280, or for 300 kilohertz. We're still reading 1.715 out of this, and we're reading 1.5675 volts approximately. So I would say across its range. Oh, the one other thing we have to do is we have to take this over to 2 megahertz and see what it reads at 2 megahertz, because that's the high end of its range. We're reading still about 1.7. We've got 1.5, 1.6. Yeah, it's waving around depending on where my hand is on the wires and things. So I think we got it. We have a working meter, close enough for me anyway. The thing is, it's not supposed to be that stupendously accurate, but it is reading exactly what it's supposed to read. So there we got it. Hey, that was fun, and it's not swaying about. However, I do want to show one thing here. Let's leave this thing here. Let's turn it off and watch what happens when I hear my battery test. I'm on batteries. Is sitting at 1, which is as close as I can get it. I know it's over the voltage, but that's what the batteries we put in. So let's turn this thing on to and watch what happens to the needle. And from what I can figure out, this is correct. First of all, it slams over to the right, drops all the way down to 0, slams over to the right again, and then slowly settles down to where it's supposed to be. And it does that no matter what range you're on. So that evidently is where it's supposed to be. Anyhow, hey, thanks for watching, and wow, this was fun, and I want to thank William for his contribution of the batteries. So It's wouldn't have got done without you, Bill. I appreciate it. So, if you like the video, give it a thumbs up, like that. And don't forget to, yeah, what do you call it? Not register, the other word, whatever. By the way, this isn't, I want to tell you, this is into 600 ohms. That's what this is over here on the LaCroix. This is a 600 ohm load. So I got to make sure to tell you that. These things work into 600 ohms. So, anyway, thanks everybody. We'll talk to you later.